Hello, I'm here with Peter and Rishwa from Replitech, and they are a local provider of filament here in Windsor, Ontario. And they've invited me here to do a tour today of their facility here, and I'm going to give them a second to talk about what they do and why they do it. So, how'd you guys get started?
Well, it was last year during the shutdown of the pandemic when everybody was sitting at home and having lots of free times in their hands, you know that. And basically, we are colleagues at a company here in Windsor, and we are designers. And we do machinery design and tooling, automation. And with this time, we started to play a little bit and with 3D printing. And we thought about building a filament extruder, a desktop filament extruder.
Okay.
So we researched a little bit.
Yeah, it's not as easy as you think when you first get into it.
Well, we very soon figured that out, and we realized that extruding filament on a desktop is not the best way to go. There are solutions out there. They are trying to do their best, but it's not easy. The process itself is implying a lot more development.
Yeah, it doesn't quite scale as well when you try to do a lot on a smaller machine. You need to go to a more professional machine when you want to produce a lot.
But we like the idea of doing filament locally, and we researched a little bit, and we figured that for the economies of scale and to have an economically viable solution, actually you have to go big.
Yeah.
So we decided to try it, and lots of filament was coming from China, and we thought that it would be a good opportunity to, especially with the pandemic and all these new economical conditions, to try to do it locally and to see if we can be viable.
That's good.
So that's how we started. Then we figure out how to manage the financing, and we figure out what kind of machines are suitable for this process. We learn a lot about extruding in general, about 3D printing materials, about how the filament is made. There's not too much information over there, so that's why I'm pretty sure that your viewers are going to be interested to see how actually this is made.
So they do have a extruder in the back here. We're going to go take a look at that later. And they are actually running right now. So we'll be able to see the process of actually turning the raw resin into filament that you can run in your 3D printer.
Yeah, so basically we are doing PLA and PLA blends. We are doing three types of PLA. We are doing a pure resin 3D 850, which is pure PLA that is developed by NatureWorks. And we have two other blends. We have Vivid and Sleek. We are going to show you how those are. And we are running all three of them, different colors. So basically how filament is made, PLA. Yep. We are going to talk about PLA right now. PLA is made from cornstarch.
Yep.
So to make the material, they are using a fermentation process. There are very large bioreactors where they do fermentation, and there are a few companies in the world that specialize in this. There are quite a few advantages of PLA material. One of the main being that it is biodegradable. Actually, it's not biodegradable, it's compostable.
Yeah, it will eventually break down. It is more friendly to the environment versus something made out of crude oil, essentially.
Yeah, and it does have a lower environmental impact. So there was a lot of research in the last 20 years in PLA field, and they came with the researchers came with pretty good recipes and technologies to make PLA. And one of the biggest in the world is NatureWorks. So NatureWorks is an American company, and I think they produce maybe 35% of the PLA in the world.
Yeah, that's something a lot of people don't realize is
Yeah.
most filament manufacturers aren't making their own plastic. They're not making their own resin. They're taking the raw material, the resin, the pellets, and they're extruding it or coloring it and then extruding it into the finished filament that we're all used to.
Oh yeah, so to produce the raw material, the pellets themselves, there are technologies that are hundreds of millions of dollars.
Yeah, you need a full-on facility just to make
And
the
NatureWorks, for example, they are making hundreds of tons a year, and it's just a small little part of it is used in 3D printing. So they are making PLA for injection molding. They are doing bags. They are doing cups. They are doing cutlery. They are doing all kinds of products using PLA. But growing percentage of this PLA that they produce, it's used in 3D printing, as 3D printing is taking off.
Over the lockdown, over the whole COVID thing, a lot of people have gone into 3D printing.
Yeah.
Because I think a lot of people have taken their vacation funds and decided to get into a hobby at home. At least that's what I've noticed. So it's really exploded at home over the past year or so. So the numbers are going up there.
Yeah, so basically we are using NatureWorks 3D 850 resin. We are importing from the States. We have big gaylords of raw material. Then we are loading this resin into a dryer, and we have to dry it for maybe 4 or 5 hours at 80 degrees Celsius. Because a very important parameter of the extrusion process is the material quality. So that's the material quality depends on how dry the material is.
Yeah, moisture, for anyone who's 3D printing, moisture will kill filament. It is horrible. You get bubbles, pops. It's not good. You want dry resin.
So when you print it, it will kill the job. But when we extrude it, it's even more. So it is very sensitive to humidity. So we dry that, and then we run it through an extruder. You are gonna see, and the extruder is basically one of the most important parts of the filament making process. So the extruder needs to have the same as you are using. In the 3D printer, you need to have the capacity to melt the filament.
Yes.
Here you need to have the capacity to melt the granules. And melting the granules is happening contrary to people believe. It's not so much the effect of the heating that we have on the barrel, but it is the mechanical work and the friction that the screw itself does have within the granules. So that mechanical work, which gives heat, is probably that heat is more than 60% of the heat that it's used into melting the material.
The screws are like my background is injection molding. The screws are like an injection molding press where they're tapered. It's not a consistent width.
Yeah.
So as the plastic moves closer and closer to the nozzle, it actually gets compressed as the screw widens, so there's less room for the plastic. It gets
exactly
squished, and compressing generates heat, and that's where actually a lot of your heat comes from.
And the friction that you create in between the granules when the screw is turning. So basically, if you wouldn't have this friction, and the friction in between the granules and the barrel itself. So it depends a lot on that friction, because if you create a layer of liquid plastic, then the screw with the granules will just turn, and it's not going to push anything. Yeah. So you need to have friction in between So the melting parameters are and the temperatures are very important. So as you mentioned, there are three regions on the screw. So it's the feeding region where you have a smaller diameter of the core of the screw, where the granules are feeding, and they do have spaces in between them, air spaces. And then you have a transition area where it is tapered, and that space becomes smaller and smaller, and the granules are squashed together.
Now, this is also helping mix in the coloring for the colors.
Well,
correct?
yeah, I'll tell you about that. And then you have the metering region, the last portion, where you have a small distance in between the core of the screw and the barrel, and they are tied together. And in that region, the material needs to be liquefied or almost completely liquefied. So what we have in the screw, so it is very important to have parameters in the screw that it's allowing for mixing. Our extruder is a single screw extruder, and it's appropriate for dispersive mixing. So unlike the twin screw extruders where you actually create master batches and stuff, yep, this one is not good to create master batches, but it is very good to mix all the colors and everything together. But to have that, so we have a barrier screw. So what is happening on the intermediate part of the screw, there are actually two sets of threads, of flights of the screw. And one of them is a lower, and so basically you are pushing the material, the solid material, and it liquefies, and it cannot escape until the material is liquefied, and only the liquid material is going into the metering
so you
section.
have no chance of anything semi-solid getting through or anything.
Yeah, because a simpler screw, it does have the possibility that you have uncompletely melted pieces of material.
Or anything like that.
Yeah, and that exactly.
Which that's common, which I've seen with the at-home filament extruders.
Yeah, and short ones.
Where you have like stuff that's not fully melted, and you're getting inconsistent extrusions.
Yeah, and actually you can have that on all the extruders where you don't have the barrier design. So after the barrier design at the top, we have a section into the screw that is called the pineapple section, where instead of flights of the screw, they are like the profile of the pineapple.
Okay.
And that is helping. It's helping a lot with the mixing of the colors, so we have a very consistent material. And after that, we do have a filter that is filtering everything bigger than
So like a little piece of cardboard gets in there, and
so
like that,
the material is filtered, and after that is going through the die, and the die itself does have a diameter. The hole in the die it's 2.2 millimeters or something like that. So another thing that people believe, and we believe too, before we started to learn that, is that the diameter of the die determines the diameter of the filament. Which is not the case. So basically, the diameter of the die is bigger, and actually, when the material is getting out of the die, it's bulging a little bit even more. Okay, and what is making the diameter? It's a balance in between. So at some point on the line, you are going to see we have a traction unit. That traction unit is pulling the diameter from one side, and the extruder is pushing from outside. So the balancing between the volume of the pulling and the volume of the pushing is creating that diameter. So if the diameter is bigger, we increase the speed of the traction, it's pulling harder, and it's decreasing the diameter.
Now, is that constantly being adjusted as it's running? So you're constantly changing
well,
the
so
push
that is constantly adjusted, because there are different forces and factors and conditions into the extruder all the time. But of course, we are not doing that manually, so that is controlled by a PLA, so it is a feedback loop through a measuring system that we have, and that measuring system is giving the information to the PLC, what diameter do I have right now, and the PLC is communicating with the traction unit, which is telling, okay, go faster because I need to go smaller, okay? And it's gonna do this feedback, but you need to have a delay into the command, because basically when you measure it, you measure at this distance and it is 6 meters where it is. So you need to have a delay, and that delay, it's a parameter that we play a lot with to get the right diameter, because if you make it too fast, it's gonna vibrate like that, the diameter, okay? If you make it too slow, the oscillations are much slower, but then you risk to get out of the tolerance that you are making.
It's better to have something. It's better to have a smoother transition between two sizes than automatically jumping up and down between two dimensions.
And that depends on the material.
Yeah.
Depends on the temperature that we have in the.
Oh, there's so many variables.
It is very, very complex. After it's getting out of the extruder, we need to cool it. And these materials, at least PLA, it's a semi-crystalline material. Okay, so the properties that are good for 3D printing are improving with the degree of crystallinity. So semi-crystalline means that there is a bunch of crystals, crystallites, they are called, within a base of amorphous material. The bigger amount of the crystallites, the better mechanical properties and all bunch of properties for the filament itself. So it is important that the material does have time to create crystals, okay? So you need to cool it slowly.
Yeah, you can't shock it.
Yeah, so actually we have 3 regions, so we have 2 bays of cooling. The first one is not cooling, is a quenching, okay? So we do have a portion where the temperature is 80 degrees. Then we have another portion where the temperature is 60 degrees. And then we have the cooling time. And we need to make sure that the filament spend enough time into the warm or almost hot water to make sure that the filament does have time to crystallize.
So basically, you're like a samurai sword. You're tempering it.
Yeah,
essentially.
Exactly. And that's why you can run with different speeds with a production line, but you have to limit the speed to a degree where you have enough time into the worm, and having hot water it helps with the roundness of the filament, and there are all kinds of parameters. So we get through that. We get to the cool water bay. Then we suck the water with a vacuum from the filament. Then it's going through the measuring system. Then it's going to the traction. Basically, the traction is pulling it. In between the measuring and the traction, there is that feedback loop. And then from the traction is going into an accumulator. So the role of the accumulator is to allow us to run the line continuously while we change the spool.
Okay, so it's a buffer.
So it's a buffer, it's an accumulator. And yeah, there are 20 rollers, and that goes for, I don't know, 4 meters high or something like that. So it's allowing us...
12 feet tall.
Yeah.
Okay, so as you're changing the spool, it's filling up the buffer, so you just don't have
so
to
it gives us about 40 seconds. It depends on the speed of the line, but about 40 seconds to work with the spool, so the line works continuously.
So how much filament, like how many meters per second is coming out of the machine usually? Or it's probably less than a meter a second, but...
It's totally depend on the line of the speed, the screw speed, and the material and the temperature.
Okay.
Well, we do one 660 meters filament spool, 600 meters, sorry, 600 meters.
Because you guys, that's one thing you guys do different. You sell filament by the meter So you're selling on a 600 meter spool instead of selling by the kilogram
Yeah.
that most other companies do,
Yeah.
which makes sense because it's volume. Different plastics weigh different amounts. So you're actually getting
Yeah.
different amounts for what you're buying.
Yeah, and I'll tell you why we would do that. So it's 600 meters is we are doing right now. We are running the line is doing in about 12 to 15 minutes,
Yes.
something like that. A spool. A spool of 600 meters, which is in PLA, it's 1.81 kilograms.
Okay.
Then we have a winder where we wind it. We have two stations, so we wind one station, then we change it and put on the other station. And after that, we do have a system that is recording the filament diameter, actual filament diameter, on a label. Okay, so we know exactly 600 meter spool, what tolerance was, what was the minimum diameter and the maximum diameter. And actually we are using that information to create two brands of filament. So one brand of filament is the precision filament. So let's say half of the spools are coming within a tolerance of plus minus 0.02 millimeters, and half of them are coming within a tolerance of plus minus 0.05 millimeters. Many times it's much closer than that. So
So you're always
Zero
aiming
point
for
zero
the,
five.
the precision, and if just one spool just happens
Yeah.
to be slightly under, that's
yeah,
false
and
precision.
that what's happening, it's on 600 meters diameter, most of it is within the plus minus, but once in a while is going plus minus 0.03. So we
Okay.
cannot, or 0.04
Yeah, so once you have
maximum.
that, you can't guarantee 0.002.
I cannot put on the label because it is not.
Yeah.
So that's why we created these two types of filament. So every day, which is fine for, we are using that all the time because most of the time it's not that important to have 0.02 tolerance. And when we do have prints for customers, we are doing 3D printing as well for them. And we have a precision part, or we are using a precision filament. So that's
Yeah, I've used both, and I can't tell the difference.
You can tell
they're
the
both
difference.
great. So.
Exactly. Yeah. So that's what's happening. We put the labor, and after that we put the filament. We have two dryers, and we put the filament in the dryer for another 4 hours. So this is for two reasons. So one is that before we pack it and we vacuum pack it, we want to make sure that the filament is dry. That's important for 3D, everybody knows that. But the filament still works, the material itself. So it continues the crystallization. Actually, even after we put it in the bag, it crystallizes for another maybe 20 hours.
Yeah, because it's still a little bit
working.
warm, right?
Yeah, so it's working. So the crystals are still forming into the material. So by doing that, we are helping it to end well, the whole process. So after we keep it in the dryer at 65 degrees Celsius for another 4 hours, we put it, we vacuum, pack it, then we bag it, and we ship it to the customer, or we have it here. So what we want to do, so why we have 600 meters instead of 1 kilogram? What we want to minimize the waste.
Yeah.
So I'm going to show you the spools that we are using. We designed the spool itself, and actually we are making here in Windsor. So we have our mold, and we have a molder that is making the spools for us, with our die, our mold. And one side of the spool is 68 grams. So two is going to be 100 and at most 140 grams of plastic that if you throw away the spool, you are going to waste. 140 grams of plastic for 1.8 kilograms of material. And usually what you have is 300 grams empty spool for 1 kilogram.
Yeah,
so it is the percentage of waste that we are with our filament is much lower, half of it. the second reason is the efficiency of the logistics. It's cheaper and for us, and we are transferring that savings to the customer for shipping, selling
you're
on Amazon.
getting-
Everything is by the kilogram, and the bigger quantity is cheaper to move
the
around.
schools aren't that much bigger than an average.
They are not, so,
school 'cause
yeah.
they're thinner. They're
Yeah, so it is on purpose. So basically, a regular spool is 200 millimeters. Ours is 210. It is wider,
yeah,
and
yeah.
Yeah,
It is
we-
bigger. It's got more film.
it
in
is.
but-
It is. Yeah, but
But
it
it's
is.
more
It
efficient.
fits on most of the printers.
Yeah.
So, yeah, that's one of the reasons. So basically, this is the process that we are following.
So we are here managing filament manufacturing and 3D printing services. So basically, we want to give a customer a good product at the end, because we've been doing the 3D printing since last 4 or 5 years, right? And we know kind of most of the issues that been involved in 3D printing, especially related to the filament. Sometimes you have the clogging, you have jamming. We recently bought our competitors' spool, and we kind of find out like there's lots of tangling, and we constantly looking at the market and what are the best material in the market. We buy them. We compare our product with against them as far as like a mechanical property wise, how it's printing, what is the advantage and pros and cons. So we know where our product is staying in front of the market, and that's our primary goal, to make sure that our filament is give the best quality and values to the customer, and they have the happy printing and worry-free printing. So basically, you can count on our material for most of the best things.
Yeah,
that
so
looking
you're
for.
seeing what the competitors are doing, and you're basically trying to improve on what they're doing.
Yes.
So, and then with because you guys do print services, you're constantly looking for the best material that you can run through your print service.
Taylor, for the local market, so we give a big discount if somebody comes here to take the filament. So we want to make it as economical for people to print as possible.
Which, considering Windsor, Ontario is so big in injection molding and the tool and mold
Yeah,
trade,
yeah.
there is like nothing here for 3D printing. I think you guys are the only ones that I know about. There's nothing
that
here.
are making here. So there are other people but they are importing from China and
Yeah,
rebranding
they're
it.
just reselling, they're not manufacturing.
And for the spools, so it cost us $2 to make a spool, $2.5 to make a spool. If you are bringing the spool back, I'll give you $2 discount.
There you go.
Okay, so you don't have to throw it away, and you get it cheaper. So it's
Yeah.
let's take advantage of all the.
Because your spools are reusable. You have the two plastic plates
Absolutely.
and then it's just a cardboard
Yeah.
tube in the middle.
Yeah, we are going to reuse it. Yeah, and we are saving all this waste.
Yep. I know, because I've been running, I've got 2 of them right now in use, and they're
Yeah.
working great.